You sent us this research paper and it dives into this concept of holographic time crystals.
Yeah, it's a pretty wild idea, huh? And it sounds like, something right out of science fiction.
It really does.
This paper, Holographic Time Crystals versus Penrose, brings together a lot of different areas of physics, actually. You've got general relativity, quantum field theory, even some condensed matter physics sprinkled in there. And to try to connect all these seemingly separate ideas, they use this theoretical framework called the ADS-CFT correspondence.
Okay, so before we get too far into the weeds here, can we maybe take a step back? I mean, I get that this paper is trying to figure out if these time crystals could actually exist. But before we even go there, what exactly is a time crystal? I mean, when I hear that, I think of some kind of glowing crystal that lets you travel through time. Probably not that, though, right?
Not quite. A time crystal is a little, well, it's a little more subtle than that. So imagine you've got a system, like a bunch of atoms, and they're in their lowest possible energy state.
Okay.
Normally, you'd expect them to, just settle down and be completely still. But a time crystal doesn't do that. It keeps changing, exhibiting these repeating patterns, even in its lowest energy state, like a perpetual uh, motion machine almost.
So it's like the system is constantly in motion, even when it should be perfectly still.
Yeah, exactly.
That seems to kind of go against everything we know about how systems behave over time, right? I mean, things tend to settle down, not keep moving forever.
Yeah, and that's why there was so much skepticism around the idea of time crystals when they were first proposed. Early on, there were even these things called no-go theorems that seemed to rule them out entirely. But then the focus shifted to these Floquet time crystals. These are systems that show this repeating behavior, but only when you give them like a little push every now and then, a periodic nudge.
Oh, so it's like you have to like wind up a clock to keep it ticking.
Yeah, kind of like that.
Okay. But this paper, this is suggesting something a little different, right? These true time crystals.
Exactly. This paper is exploring the possibility of time crystals existing without needing any kind of external force. Like they just arise spontaneously in certain quantum field theories.
Wow. Okay. That's pretty mind-blowing. And this is where the ADS-CFT correspondence comes in. Honestly, that whole thing still sounds like well, like a mystery to me.
Sure, it's a complex idea, but it's also incredibly powerful. Okay, think of it like this. You've seen a hologram.
Right.
So a hologram is like a two-dimensional surface,
Right.
but it can project a three-dimensional image.
Right. Yeah.
Well, the ADS-CFT correspondence is kind of like that. It suggests that a theory of gravity in a higher dimensional space, and we call this space anti-de Sitter space, is actually equivalent to a quantum field theory on the boundary of that space.